Okay, hey guys, so sorry for the new setup. I'm actually on holiday at the moment, and excuse the very blue nails from tie-dye. But let's jump into question 5. So it says, the table below shows the number of passengers that were on a bus after every stop. Okay, it goes 2, 20, 34, 44. So we can see it's increasing, right? But that increase is getting smaller, right, with each stop. So let's now read the next sentence they've given us. The number of passengers on the bus after the nth bus stop can be given by Tn equals An squared plus Bn plus C, where A, B, and C are elements of the real number system. Right, so what's important here is this is the general form of a quadratic, right? So they've actually just told us that we have a quadratic series. Okay, that is so important. When we know it's a quadratic series, we know there's a constant second difference. So we already know a lot of information now, right? Which if you didn't recognize this, you would be like, wait, well, how am I supposed to do this? I'm like, feel like I'm stumbling around in the dark, but it's important to understand the different ways that this can be represented. Okay, so I've written that out for us. Then it says, write down the number of passengers on the bus stop after the 5th stop. So what I've done is I've written out the first 4 terms. I've written out the first difference, right? And you might be saying, Margs, what's the first difference? Well, it's 20 minus 2, 18. 34 minus 20, 14. So you're saying a term minus its previous term, okay? And you get this. Then remember, constant second difference. We now want to see, you see here, oh, excellent, right? -4. Okay, then, so that's our constant second difference. So to get this 5th term, we say, okay, here's -4. What's 10 minus 4? 6. So then what is 44 plus 6 is 50. Okay, so 50 is our answer there, right? So you could say 50 passengers. I always think it's better to be more specific, right? Because it's not 50 bananas, right? It's 50 passengers. You're saying, you're demonstrating to your marker that you understand what's going on. Okay, so that was sort of an entry-level question. It helps you identify what this question is about. It gets your mind in the right mind frame. Okay, now we get to the question we all knew was coming about A, B, and C. Okay, now, because we know it is a quadratic sequence, okay, there's a number of things we know. We know that 2A equals the constant difference. And we know that 3A plus B equals 18. Okay, so those are what we have there, right? And you might be thinking, good grief, Margie, like, how do you know these things? And we also know this, right? So you could be thinking, oh, Margie, like, what are you doing? What are you doing? But what I'm doing is I'm using the properties of a quadratic series. Now, if you're like, I don't know these properties, Margie, what are you talking about? I would advise you to go to my maths core playlist for DBE and go to the quadratic series video and go watch that, right? Because I explain how you get each of these formula, okay? I'm not going to do it now because those are available to you if you want that, right? But here I've written basically 3 simultaneous equations, okay? And because we have 3 unknowns, that works out nicely. 3 simultaneous equation allows us to solve for 3 unknowns. So let's start with the easiest one and work up to the most difficult one. So A is going to be -2, right? Because there's only one variable there. There's a constant and we can solve for it. Here we can then sub in A and solve for B, right? So B, right, is going to be 24. Okay, I hope you're following me there, guys. I don't know if I'm making any mistakes. If I am, you can always shout in the comments, but I think it is all right for now. Okay, then let us now put this into the last equation. Because now we have A, we have B, all we have to solve for is C. Okay, -22 plus C equals 2. So then C is going to equal, oh, you see, this is not negative, that's positive, right? -2 plus 24, right? It's positive 22. So this is going to be -20. So, right, just said A, B, and C, so we've technically done that, but I just want to write what Tn looks like, right? Tn is going to be -2n squared plus 24n minus 20. Okay, it's always good to keep in mind this, right? And that the A, B, and C aren't just these random numbers, right? They're actually coefficients and constants within a quadratic series. It's important to keep that in context. Okay, so that's that. Let's now go into the next question, which is bound to ask us some very difficult question about this, but we will master it. Don't worry. Okay. Oh, look, it says, if it is given that Tn equals negative 2n squared plus 24n minus 20, which is exactly what we got. So that's fabulous. We can basically mark our previous question correct and give ourselves 4 marks. Don't do that, though. It comes across very arrogant. It says, determine the maximum number of passengers on the bus. Now, you're like, what does that mean? But when you see words like maximum and minimum, guys, you should be thinking derivatives, right? Derivatives is what help us find that, okay? So if we say Tn equals negative 2n squared plus 24n minus 20, then my derivative, use this notation, is going to be negative 4n plus 24, okay? So that helps us there, okay? So now you might be thinking, okay, we've got the derivative, but how does that help us? Remember, when we're finding a minimum or a maximum, we set the derivative equal to 0. So now we say, well, that's 0, right? And we solve for n. So if you solve for n, right, you get that n equals 6, right? And then we know that the max, right, is where n equals 6, but let's sub it back into this equation, right? Because it wants to know what the max number of passengers is, not at what bus stop. 6 is just the number of bus stops, right? But it wants to know the number of passengers. And that's why it's important to read your question. Because if you just got n equaling to 6, that's very nice and well, but you wouldn't have got all the marks. Okay? So let's just put that into our calculator. Oh, what? I just threw some trig up in here. That's in the second paper. Stay away, trigger. It equals 52. So the max number of passengers is 52. Importantly, okay? All right, let's just go through that. We got the derivative. Why do we get the derivative? Because it helps us find the maximum or the minimum. Remember that I use the shortcut to derive here, right? You take the variable, you take the exponent, you bring it down, you multiply it by the coefficient, subtract from the exponent. Here you keep the coefficient, right? Because there was only n to the 1 there, so it falls away. And because it's a constant, there is nothing there for it from a derivative perspective. Set equal to 0, solve. Okay, let's now go to the last question for this question. It says, explain why the formula given in question 5c does not work after the 11th stop. Okay, not work. That's interesting. So what we can do here is as well, what comes after 11? 12, right? So let's just see. When I say n equals 12, let's see what T12 equals. Okay, I'm wondering myself. I'm like, well, why doesn't that work? Surely it should. But there's no need to fear, right? This is something that is a good technique. If you don't understand what to do, just do one thing. And often that leads onto a good thought pattern for other things, okay? So let's put this in. Substitute in 12, right? So 12 squared plus 24 times by 12 minus 20. Oh, well, there seems to be negative passengers at time 12, which is a little bit of a problem, right? But let's just check at T11. Let's see whether it's maybe positive at T11, right? Because we need to know why it's after time T11, right? After the 11th stop, because if it doesn't change between 11 and 12, maybe it's not 11, that's the number that it changes after. You know, we have to corroborate, we have to confirm that this is correct. So let's just do it for 11 and see what it is at 11. So you can keep it in your calculator. Just go back, right, and make these 11s. You can retype it if you want to. I'm just trying to be a little bit quick. So that says 2 passengers. Okay, so we see that between stop 11 and 12, it stops working because you can't have negative passengers, right? I mean, how do you have negative passengers on a bus? You either have nothing or some positive number greater than 0, right? You can't have nothing. So the problem is you cannot have a negative amount of passengers. Okay, right? And we see that the reason that it's after 11 is because 11 is the last number where we have a positive number of passengers, and then we're heading into the negatives. Okay, so they're just testing that you understand what these series mean, because there's no point in just having a general formula. You must understand how it's applied, right? And where sometimes it falls short, or how it actually can be used. Okay, I hope that was helpful. So we're pretty much halfway through the paper. Okay, we're going to move on to some functions. We have a bit of probability coming up. There's lots of fun things, but I hope that was helpful, and I will see you in the next video.